Hey, what's up, guys? Chung here again. So today, let's talk about another LeetCode problem. Number 325. A maximum size subarray sum equals to k. And you're given like an array, right? Consists of different integers, and it could be it could be positive integers, but it can also be negative numbers. And then you're given like a case here, which is the target sum here. It asks you to find the maximum length of the subarray whose sum equals to this k. Okay, for example, this one, for this one, the longest, basically the longest subarray is 1, -1, 5, and -2, right? That's the sum of this subarray is equals to 3. So how about this one? This one is like the 2, right? Which is the -1 plus 2. That's the sum equals to 1. And if you if there's no such subarrays, then you return 0 instead. Okay, so I think the first naive also like brute force solutions will be we simply have a nested for loop, right? We do a for loop, we loop through all the subarrays, and for each subarray we get its sum, and then if that sum equals to k, we get we get the length of the current subarray, and then we'll be comparing with our result, right? Our result which will be storing the maximum subarray, the maximum length, the maximum length of the subarray uh whose sum equals to k, right? I think for that I think it's a kind of brute force because to loop through all the subarrays, the time complexity gonna be n square o square. Sorry, it's gonna be n square. And also to get the sum, I sum of those subarrays, it's also like for each of the for each of the subarray to get the sum, it's also like an n. So the total complexity for that brute force is something like O n to the power of 3, right? Which it would be too much, right? Too slow. And also it asks you, can you do it in the time of O(n)? Can we? Yes, the answer is yes. How, right? I think one thing we need to keep in mind, we need to know is that we have this pre-sum concept. Basically, we for each of the elements here of numbers here, we do a running sum, right? Basically, we just keep adding the sums here. And with the pre-sum result, what can we get? We can easily get the sub-array's sum from the running sum, right? Then what's the pre-running? So let's say, for example, if you wanted to get the sum of the from I to j, right? So the sum from I to j is to what? Is equal to the pre-sum j, right? Minus pre uh, I minus 1, right? So with this pre-sum, we can easily get the sum of any subarray. Okay, so then I'm gonna do this. Let's say we have a example here. 1 minus 1, 5, see, 4 minus 4 and 3, right? And k equals to 3 here. So with this idea here, how can we do this thing, uh, solve this problem in one path, right? Basically, then in order to do that, we all we also need to create like a hash map, right? So the key will be the sum, and the value will be the index, the smallest index. Okay. So every time when we see a when we see a number here, uh, if this running sum, the running sum is not in the hash map, we add it in the hash map, right? And meanwhile, we just do with the current running sum, we use the running sum, the current running sum minus the running sum minus k. Okay, we use the current running sum subtract k, and we see if this one is in the hash map. Okay, so what will this tell us, right? So let's think about this. So if this thing, if the running sum, the current running sum minus k will is in the hash map, what does it mean? It means that there is like somewhere, there is somewhere before, let's say for example, we're at here, and there is like the running sum will be like uh 1 0, right? And then 5 3 running sum here, 7 3 and 6. Okay, so let's say for example we're at here, and we use this minus uh 3 minus 3 equals 0, and we see, okay, for example, let's say we find this thing here. If we find a previously running sum somewhere already in the hash map, it means that, okay, so there is already a place where whose like running sum is equals to this. Then it means from that point to our current point, the sum of those subarray is equal to k, right? That's how we can get from this formula here, right? Then we know, okay, we have a subarray whose sum is equal to k, right? And then since we're always keeping the smallest index for that sum, so and we know at this point, right, the at this point the subarray the subarray we get at this position must be the longest one, right? I mean, by so far, right? We don't know what's later on, what's on the right side, but we know at this position, if there is something, if there is something in the hash map, we and using that index, comparing with the current one, we use the current index minus the current index we saved in this hash map. We know that's the biggest or the longest subarray we can get. Uh, by far whose sum is equal to k, right? And then we just keep going it until we reach the end, and then in the end we know, okay, we have a we have the we will have the our solution, our answer, right? uh I know the explanation is kind of it's not that clear, or maybe maybe it's just that I did a terrible job explaining this thing. But okay, so with those in mind, with that being said, let's try to code this problem here, right? So like I said, we need a hash map, right? So uh, indexed dictionary, right? And oh, sorry, one more thing before we start coding is, let's say we have a 1 and 3. Let's say the array is 1 and 3, and the k is 4. Okay, so So what result are we expecting? 2, right? But if we just follow our previously introduced solutions and we have a hash map, we have a hash table, right? And then we have hash table, and every time when we see a new sum which is added. So in this case, we see 1 here, right? The index 0. That's why we add like 0 and a 1, right? And then we see a 3 here. Okay, when we see 3 here, the running sum is 4, right? So 4 minus k equals to 0. We are expecting, sorry, this is uh, the key is the sum. The value is the index, sorry. And when we see the 0 here, we see we're trying to look for the 0 to, if there's any element in the hash table whose key is 0. But in this case, it's not there because all we have is a 1, right? But we're hoping we can find one. That's why we need to, when we create this index dictionary, we need to put like an initial position. The value will be, the sum will be 0, and the index will be -1. Right, so that will make sure when the array starts from the first positions, we can have the correct answer, right? So in this case, the index is of the current of 3 is 1, right? 1 minus 1 will be 2, right? Will be our result. So cool. So with that, let's see uh 1 0 1, sorry, 0 minus 1, right? And then we just simply loop through the numbers here, right? And since we need both the index and the number itself, let's do a enumerate here. Enumerate. Synonyms here. Okay, like I said, first we check, right? If this k, sorry, if the running sum 0 and answer equals to 0. So first we update the running sum, the number, right? If running sum minus k, right, is in index dictionary, right? Then we do what? We do an answer, right, equals to max answer, right? So we update the final answer by using the current index minus the index we stored in the dictionary, right? And then gonna be running sum minus k, sorry, minus k, right? Okay, so that's that. And after this, we check uh, if this running sum not in index dictionary, right? Then we just save it there. We save this because we want to store the latest, the earliest index, right? That's why we do a check. As long as since we're scanning from left to right, so that's why we only save this sum with its index once. And in this case, dot running sum, right, equals to I. Okay. In the end, we simply return the answer here, right? So yeah, I think that should do it, right? So because now let's just try to run it first. Okay. Yeah, so it passed. So basically, we're just maintaining like dictionary since we're only looping through these numbers once, and the lookup time for the hash table or dictionary is 01, right? Every time we do a running a check here, it's always 01. So that's why the total time complexity is ON. Uh, and also one thing to be noticed here is this like the initial state here. Cool. I think that's it for this problem. And yeah, thank you so much for watching the video. Yeah, it's been a long day. I had a long meeting tonight today, so kind of tired. But anyway, thank you so much, and I'll be seeing you guys soon. Bye bye.